For section 1.5, we're now going to do some applying problems with our quadratic stuff that we've done. Before we get into the examples, we will have to use the Pythagorean theorem at a few points here. So just a reminder that Pythagorean theorem is a squared plus b squared equals c squared. But again, that won't work on every problem, but it will show up. So on number 1, we have a machine making rectangular sheets. The length is 3 times the width. So first thing I'm going to do is if I call the width W, so from here to here, we'll call that W. That means my length, instead of writing L for length, I'll just write it as 3W. Now, squares are cut from the corners, so the resulting piece of metal can be shaped into a box. Okay. So if they are 5-inch squares, these are all going to be 5 by 5. All the way around here. So the idea is this is going to fold into an open top box. So imagine folding here, folding here, here, and here. So we're going to fold it up into a box. We want a function for the volume of the box. So this is going to get folded into a box where the base is that red rectangle that I drew inside there. And it's going to get folded up into a box. Remember that for volume, it's length times width times height for a rectangular solid. Well, we need to get an expression for the length of the box. Now, here's where it gets a little tricky. It's not 3W anymore. It's 3W for the entire length, but we removed that length and that length off of that. So this would be, what's left over is 3W minus a 5 minus a 5. So it's going to be 3W minus 10 inside of there. So that's my length. Similar idea for the width. The width originally was W, but I cut off 2 5-inch squares. So it's going to be W minus 10 for the width. Over here, my width is W minus 10. And then if these flaps on the sides are getting folded up, that means the height of this thing is going to be 5. So my length is 3W minus 10. My width is W minus 10. My height is 5. So find a function for the volume. I'm going to multiply all these together. I'm going to use functional notation here just to get us more accustomed to it. This would be volume in terms of the width, because that's the only variable I have. So it's going to be 3W minus 10, W minus 10, and then times 5. So if I FOIL those together, that's going to give me, if you multiply it all together, combine like terms, 3W squared, let's see, minus 40W plus 100. And then everybody still needs to get multiplied by 5. So if I distribute a 5 through all of that, I'll end up with my final formula for the volume. So the volume in terms of the width, and remember that's the width of the original sheet, is there. And notice it built a quadratic. We have an x squared. Well, in this case, W squared. Now, fortunately, on this one, it's not asking us to solve anything. We just have to write it. On number 2, this looks like a vastly different problem, because it is, but it will result in a quadratic still. So you hike 6 miles north. Okay, so we'll say that's 6 miles north. 8 miles east. 8 miles east. 2 miles north. And finally, 4 miles east. Question is, how far are you from where you started? Well, I can't just add those up because how far I am is going to be where I started to where I finished in a straight line. So I have to figure out the length of that black line there. What I can do, and this should bring back fond memories from geometry, I can build myself a little right triangle with that black line being the hypotenuse. And this is where Pythagorean theorem is going to come into play. So focusing just on the triangle down here. The base of that triangle is going to be 8 plus 4, so 12. The height of that triangle is going to be 6 plus 2, or 8. And now I can just apply Pythagorean theorem. 12 squared plus 8 squared equals c squared, which is the black line that I'm trying to figure out. So this would be 144 plus 64, which is 208. This technically is a quadratic that I'm solving. It's a very simple quadratic, but I do have c squared. So to get c by itself, I'm going to take the square root. Now, technically, I'd usually have a plus or minus out in front of this, but I don't need that on this problem because I'm talking a distance, so I know it's going to be positive. And if you break down 208, if you factor tree it down, you'll end up with a reduced or a simplified radical of 4 root 13 miles. Again, doesn't seem like a quadratic problem, but it really is. For number 3, find 2 consecutive odd integers whose product is 63. Well, I'm going to call the first number x. Now here's the hitch. The second number, well, if it's a consecutive odd number, think like 3, 5, 7, 9. You bump up 2 from one odd number to the next odd number. So from x, the next one would be x plus 2, because it's a distance of 2 from each one. Whose product, okay, so that's going to be x times x plus 2, is 63. Well, this looks like it's going to turn into a quadratic. If I distribute, I'm going to have x squared plus 2x. If I subtract over the 63, this looks like a factoring problem, maybe like an X method. And this one will factor into x plus 9, x minus 7. Now here's where you got to be very careful on this problem. These are both possible x's, which means they're both possible first numbers. So from the first factor, the x that would make it 0 would be -9. So -9 is a possibility for x. For the second factor, 7 is a possibility for x, which would mean that the second number in each one of these cases, I'm just going to add 2. So in the green one, -9 plus 2 is -7. For the red one, 7 plus 2 is going to give me 9. So I really have 2 possibilities. Either it's 7 and 9, which is probably ones you could have guessed at the beginning of the problem. They do multiply to 63. But what people will often forget is that -9 and -7 also are consecutive odd numbers, and they also multiply to 63. On number 4, we're back into some geometry stuff. One leg of a right triangle is 5 centimeters, okay? So it'd probably be beneficial to draw myself a right triangle. One leg is 5 centimeters. The others have lengths that are consecutive integers. Okay, so not consecutive even or consecutive odd, just consecutive integers. That means one of them is going to be x, and the next one is just going to be x plus 1, one bigger. Well, x is definitely smaller than x plus 1, so that has to go for the other leg, because the hypotenuse has to be the biggest, so that has to be x plus 1. Well, I've got a right triangle. Feels like Pythagorean theorem is probably going to come into play. So leg squared, so that's 5 squared, plus the other leg squared, x squared, equals, here's where you got to be careful, the hypotenuse, x plus 1 squared. So if I square x plus 1, again, remember, that's not just squaring the x and the 1 off to the side, FOIL it out, multiply it by itself, you'll get x squared plus 2x plus 1. On the other side, I've got 25 plus x squared. Fortunately, on this one, even though it is a quadratic at this point, the x squareds subtract off, and I'm left with a much simpler problem. So I just got to subtract 1. So 24 equals 2x. If I divide by 2, I get that x is 12. So what was x? X was the other leg. So that's going to be 12 centimeters. The other side would be 12 plus 1, so 13 centimeters. So those are my other two sides. Okay, that'll do it for this first video. We'll finish up this lesson in the next video.